Hello, Warsaw. So how did you like the conference so far? By means of strength of your applause, give it to the organizers. All right. So far, the conference has been great, a great success, but we still have 1 hour. Anyone needs to be on an airplane, needs to leave early, we need to cut it short. All right, well, I do, but what you gonna do? I'll sacrifice. So, okay, I'll tell you first what I like about Polish programmers. Do you realize how tense this moment has become suddenly? All right, my career depends on what I'm gonna say next, right? So what I like is the poker face. So you give a talk in Poland, and people are like, yeah, whatever, and they give you the golf clap, yeah, sure, fine. All right, so the same evening, after a couple of beers, they're like, I loved your talk, man. That's so nice, oh, I loved it. And I'm like, I love you too, and then we cry on each other's shoulders and that kind of stuff. So that's great, I love the poker face. And today we're going to talk about JGPD, right? The history of this talk, thank you, is that initially the organizer said, oh, why don't you come to our conference? I was like, okay, interesting. Would you like an AI talk about what's going on at NVIDIA with AI and stuff? And they said, yeah, sure. And then a month before the event, they said, well, actually, we want some C++ material, because everybody's expecting that you do C++. And then I'm like, oh, I got to change my slides. So I changed my slides, and literally 1 week before the event, I figured out that actually they had me deliver the keynote, which is difficult. Like, how many of you don't even use C++? All right, so this is a good crowd, awesome. So the few of you who raised your hand, I'm really sorry. So by the way, one thing before I go, who knows what ESQ stands for? Just shout, just yell. What does ESQ mean in English? ESQ. Esquire, thank you. Well, what does Esquire mean? It means two things. In American English, like USA, it means you're an attorney, a lawyer. So they say John Smith, Esquire, and it means you're a lawyer. In European English, it means you have a little problem. Not a big problem, you have a little problem. By example, a couple of months ago, I was flying to Europe, and I was flying with a German airline. I'm not going to say the name, I don't want to get into legal trouble, so I'm going to call it Grundhansa. Just, random name that. So I fly Grundhansa, and then there's a huge strike at the Munich airport. And they say, well, your ticket is canceled from first class, whatever, business class, whatnot. We're going to put you on a, 23 hours economy flight with 3 legs. I don't want that, so I booked my own other ticket, and I, went my way, and I said, well, where's my money? I paid money for this, I didn't use it, so. And they said, we're not going to give you your money back. And I said, oh, no problem, this is Europe, civilized country, come on. So I wrote the German Consumer Protection Agency. Awesome. I see some nods, maybe some of you know about it. So I wrote the Supreme Consumer whatever Protection Agency in Germany, and they wrote me back a letter. A couple of weeks later, I got a letter, paper letter, to my name, Esquire. Thank you very much. And dear Mr. Whatever Esquire, we inform you that we're not going to give you your money. And that's the funniest part. We referred you to the Consumer Protection Agency in Romania. But my passport was not from Romania. Nothing of my identity says I'm Romanian except my SQ, my last name. So I suspect there's a German, person was like, SQ, Romanish. Let's get the money from Romania. So I'm sure I'm gonna get my money. Awesome. So let's get into it. Natural language processing is making huge progress, isn't it? So there's a lot of data needed, there's a lot of computation needed. We are at this interesting junction in history that has us wow, something's going to happen soon, and in the future, I predict that computers are going to start reading web pages and understanding language and that kind of stuff. And at this point, you may be thinking, why am I here? Like, this guy is kind of out with the times, right? But please note, this is the slide from 2007. I gave that talk in 2007, and I'll have my I told you so moment right now. Thank you very much. Right? Poker face. All right. So, I gotta say, a lot of that good stuff did come to fruition, and we cannot afford to ignore what's happening with JGPD and coding and systems coding in particular. We just can't afford. You can hate it, you can like it, dislike it, whatever, you can have an opinion, but you can't afford to ignore it. You can't afford to not know about it. Right, so that's my point here. All right, so by means of agenda, we're gonna talk a bit about how these large language models work and what makes them tick. Then we're going to use a few examples on how to use JGPD for programming, in particular systems coding. Then we're going to change gears a bit. We're going to talk about creativity, taste, and skill, which is kind of a meta discussion of sorts. Then I'm going to venture a couple of predictions, which are going to age really badly. And a year later, we're going to watch this and you're going to be like, oh, that idiot, right? All right, let's see. So, first of all, I noticed many programmers ask these important questions about how these LLMs work. And first of all is, how come these machines train on text that's not annotated, it has no meaning, it has, essentially there's no training data for text. There's no way to learn, oh, this sentence means that. There's no that, right? It's just the sentence. And actually, that's what kids do. It's called language acquisition. It's not language learning. So kids just pick it up from nothing because they don't have anything there. But I would argue that human language is everything that's about us, right? It's an embodiment of who we are. Everything is in language. And, I have no words is kind of a metaphor, I have no words to describe how I feel right now or what's happening right now, right? I mean, that's rare, to literally have no words. What's an example? Do you remember Jaruzelski? I'm not sure, he's bad, right? So the history says he's bad. Okay. So while you were with Jaruzelski, we were with Ceausescu, right? And at that point in 1984, there's a poet in Romania who wrote, there are no words to describe the awesomeness of the dictator. There are no words. And everyone's like, really? I have a few, I have a few. So, really, the fact that we have word with, for example, like a language model did not have its heart broken, right? It did not, and I did, or you did, and we all did. We're humans, so there's a lot of experiences that the language model or AI did not experience. At the same time, who here killed a man? Nobody? All right, good. So, there's a lot of things that we did not do, but we do have an academic understanding of because we read about them. We read about Raskolnikov, right? And a variety of other writings about a variety of human feelings and endeavors, right? So, understanding language is really understanding everything there is about being human. If you understand language, you understand humans. And there's a great talk on TED about how AI can be so smart and stupid at the same time, and it makes the thesis that LLMs have no common sense. And I would disagree, and I do recommend it's a great talk, but I dare to disagree because I think there's a lot of common sense embedded within the language. Common sense means if I'm in Warsaw right now, where is my left foot? Right, that's common sense. And actually, if you ask ChatGPT that, it's going to give you a very good answer. Assuming it's still attached to your body, it's going to also be in Warsaw. Also, it said, assuming you're not right on the border of Warsaw or something. So it was kind of a very precise and interesting answer. But they do have some common sense because the language embeds common sense. So another question that I see is frequently asked is, how do we get from predicting the next word, which is a seemingly trivial endeavor, to all of this intelligent behavior of JGPT and others? Well, predicting the next word is not easy. I mean, it's really pretty much language complete, because you need to have long-term memory, short-term memory, combine them, reason, and say, the killer was whatever in the Agatha Christie novel, right? Or in the math proof, you gotta say X and Y are equal or not equal. And essentially that means you gotta reason about the whole text you've seen just to predict the next word, is false or true, right? So it's not a trivial task. I should say, however, that in the past, there were these n-grams models, and it was, when I was a graduate student, language modeling was considered a solved problem, because they said, you need like 6 words of context, and with statistics you do it. It's called IBM n-grams model. It was famous. So it's not that easy, actually, and you need a lot more context to really predict the next word. And once you do have those probabilities of the next word to appear, then you run it backwards in generative mode, and that was a key finding of these large language models. You have the probabilities, and then you can generate plausible text, right? So that's how it works. It can predict, it's not only the most probable word, it's a whole distribution of the entire vocabulary of what the next word could be. So it's like a Gaussian, right? It's a distribution over the entire vocabulary. And then when you run it the other way, it's gonna generate sentences that are pretty good. They're new too, they're not existing sentences, right? So now, the third thing that I wanted to convey about these language models is that they are continuous. Continuous. It's all continuous representation. What do I mean by that? We humans have the tendency to approximate the behavior of intelligent systems with sort of the most complex mechanism that we think of. For example, who remembers like Kempelen's automaton who was playing chess? Like in the Renaissance times. Okay, the Mechanical Turk. All right, so that's the name, right? The Mechanical Turk was a contraption that was like a clockwork, because clockwork was the most complex mechanism at the time, and the crook who invented the Mechanical Turk, he claimed it's an automaton, but there's like a guy inside of it and that kind of stuff. But it was all gears. It was gears and stuff. And then, the steam engine was invented, steampunk, like, it's like your brain is like, some steam engines and stuff. And then the transistor was invented. It's like, it's like some transistors and stuff. And then the 80s came, and there's like all programming and if-else, right? And while and for and whatnot. And it was assumed that the brain is like an expert system, like if and else and whatever, right? Nothing, LLMs today work like nothing like that. They're not steam engines. They're not clockwork. That was a joke. That was a second joke, like zero. Like the poker face goes like, fantastic. I'm gonna die over here. All right, so that's the interesting thing. It's not like in the books of the 60s and 70s and 80s, because if you remember, there's this Isaac Asimov, he said, robots are logical but not reasonable. Actually, I would say, ChatGPT is most of the time very reasonable. Kind of gives reasonable answers. And why? Because they're derived from reasonable language. I'm afraid I cannot do that, Dave. It's a quote from the Space Odyssey 2001. And it has to do with an image of these robots as if-then-else machines, whereby you have an expert system, and in that case, there's a cognitive dissonance, and they loop forever, the brain explodes, all these movies, right? So it's not like that. It's all continuous representation. And the way it works is the machine essentially simply learns continuous representation of words and phrases and sentences and entire concepts, and it understands that cat is closer to the dog than umbrella. So then if a cat is running through the yard, a dog is running through the garden. because garden is close to yard, so it can generate infinite similar sentences based on this continuous representation. Yoshua Bengio was the first who published such a paper. He said, let's use it. It was the late 90s, I think, and he said it's about time that computers have gotten fast enough, so we can actually generate learn some continuous representation using a neural network, and the whole thing was born, right? So that was a seminal paper. So also don't forget that a lot of art and science comes from fitting old patterns to new content. Like in music, it's all patterns and that kind of stuff, and there's infinite ways to create music with the same pretty much 12 notes and a few musical patterns, right? Applied to C++ code in particular, you gotta give it to it that it's pretty remarkable that JGPD generates C++ code with close parentheses and close braces and kind of correct semantically, syntactically, and it does no grammar. It did not learn, it doesn't have like a grammar of C++ in it, except implicitly acquired, right? So that's kind of an interesting, remarkable fact, right? It's also great at finding typical bugs because bugs follow pattern as much as good code. There's a lot of code on GitHub and a lot of blog entries and whatnot that illustrate bugs off by one and modifying a container while iterating all that nonsense. And it's easy for JGPD to pick up those bugs and find them for you. So that's pretty remarkable. I mean, on the face of it, you can think of it as a quite inefficient way of going about things. But the fact that it's so general makes it quite remarkable. So that's pretty awesome. And a classic keyword in machine learning is generalization. It can apply pattern from one problem to another problem, right? And this is where quite a bit of creativity comes in. Awesome. So let's actually use a bit JGPT for writing a little code. And here I would like to differentiate between two kinds of code. It's not, mind it, it's not a strict categorization. It's not something that I'm kind of very hard and fast about, but I'll divide the world of programs into two, a high-level application versus low-level systems. And in the application programming space, you would have the interesting part is the business idea, is the business logic. It's the whatever idea you have for an application. And the code is what takes you there. In a way, the code is on your cost, in your balance sheet. Is like, yeah, I got to pay these coders. I hate them. Right? Poker face. All right. So, I got to pay this quota. So they're, and I actually have friends who are like in financial institutions and a variety of non-tech companies, and they are on the cost side of things. And, they're paid differently. They're not a lot less, but it's just a different way of looking at things. They're paid differently. The bonuses go differently. The entire structure is differently, and they're on the cost side of the balance. You use whatever libraries, APIs you find, and essentially you want to get from 0 to 1, from not having anything to having a, MVP, minimum viable product, in hand, and that's what matters to an application program. There are many paths to getting something done, and the patterns of use are quite easy. You give the application to folks, and folks have quite predictable patterns of using the thing, so it's not a huge variability there. Whereas with low-level systems programming, things are quite different, I would argue. It goes, wait a second, actually the code is my asset. So the code is, the crown jewels is like, the family heirloom. Is the good stuff, right? My coders are awesome. They're on the product, they're on the other side of the balance. They're not cost, they're value, they're assets, right? So these coders are going to implement things that application programs are going to use. They're going to implement these. Right? They're going to give them to people. And actually, you'd be surprised that the right path of doing things is much narrower. If you look how to replace a string with another string in Python, there's like literally 50 blog articles. I saw them. But if you want to replace something with something in C++, it's actually the optimal code is pretty narrow. There's not a lot of ways to do it efficiently, right? So that's why I'm saying the right path is very narrow. And there are many constraints, either implicit or expressed, and performance, size of code, you don't know how people are going to use it, so it's very unpredictable how the usage pattern is going to go, and that kind of stuff. So, the dynamics here is quite different, is what I'm arguing. So in light of that, I took ChatGPT 4 for a code interview, and I said, let's see what you do. And by the way, so you know the movie The Shining, right? Yes. Okay. So from Shining to The Shining, the title of the slide was recommended by ChatGPT. No kidding. So actually, I told ChatGPT, I want to illustrate this, with a funny metaphor involving some movies, and said, oh yeah, from Shining to The Shining, that sounds great. Thank you very much, ChatGPT. I'm going to make fun of you in front of people with flesh who suffer and have their heart broken, and that kind of stuff. So I asked questions such as, implement strstr, the simplest function I can imagine that is not actually trivial. And then I gave ChatGPT a different function, the second one. Let's take 2 pointers to float, and they point to arrays terminated by nan, not a number. And, find one in another. Do you notice the similarity between the first and the second? Right? The second is actually str on floats. Right? But there are a couple of differences. One is that they end in nan, not in 0. And that makes for an interesting optimization because, nan compares with nan how? Who knows? Nan versus nan. Is nan equal to nan? Is nan different from nan? All right, does anybody use floating point numbers? Okay, so if you tell me. Behind you. Is nan equal to nan or not? No. Is it different from nan? Yes. So nan is not, it compares unequal with anything including itself, right? So you can use that as an optimization, right? And that makes the optimal function that finds floats in floats different from the function that finds strings in strings, right? Another prompt for remove unstable, which was proposed for standardization in C++, given an array of integers, remove all zeros from it and compact the array to the left. And you can put the resulting numbers in any order, so that's what makes it unstable and more efficient, it turns out. Turns out that unstable remove can be much faster than stable remove, which is what exists right now in the C++ standard library. So I gave these prompts to ChatGPT 4 in an attempt to get a working solution to then, optimize and, get better and better and better. And that's the point of an interview. You want to see if somebody has systems thinking. They can look at code, reason about it, understand, do some analysis, and get it better than it is. Awesome, but then I got a bit more meta. I said, okay, so you are a programmer using an assistant, give it prompts to generate code for you for the problems above. So that's the second level, right? Because I was like, do I need to write all this nonsense myself? How about I tell, ChatGPT to tell ChatGPT to do X, Y, and Z, right? Pretty interesting. And even better, I made ChatGPT the interviewer. I said, why don't you interview me and other ChatGPTs? See what the hell happens. What do you think happened? Did I get hired or not? Would ChatGPT hire me? Or would ChatGPT hire you? Oh my God, okay, so we can't have the situation where nobody raises their hand. We can't have that situation in this room. Okay, 2 hands in the back, thank you. People in the back are the best. 3, thank you very much. We'll see if we make it. All right, so I'm not gonna get into this very much, but just to tell you that seemingly trivial problems are not trivial at all. It turns out that this function is optimal str brute force, and if you change as much as a white space, it falls apart. So there's no 2 ways to write this function. And the fact is, nobody has implemented it in the past 30 years. Why? Because it's implemented as an intrinsic in assembler on all compilers because it's frequent. Everybody uses str, and because they use non-portable C++, they compare 4 bytes at once. It turns out this function is only 2 times as slow as the built-in. And it's optimal. So things like if you actually, on this last line here, if not h-break, if you test not haystack, you're still going to pass all unit tests, but you're going to be like, 100 times less efficient. I'll leave it to you to, I'll leave it to you to kind of stop the video right now and look at the slide. We stop, right? So that's why I'm saying the path is very narrow to writing right code, because most candidates. So literally, like I interviewed like 300 people. 0% wrote the right str. And that includes me. I had to sit like 1 hour on this. I'm not kidding. I sat an hour on this. Just gotta figure out like how the hell does this work? I don't wanna do extra work. I don't wanna compare 2 things once. So it's only 2 comparisons in the inner loop and 2 more outside, 1 more outside. And essentially you can't write it with classical for loops and for I 0 to n, whatever. It doesn't work like that. You can't do structure loops. So it turns out it's much more difficult than it looks. And my goal was to get JGPT to write me any str and then make it better. Well, yeah, that was not the way the things worked. First of all, JGPT produced working code for each problem. And the problem that occurred after that was it got increasingly less convivial, for the lack of a better word. It could not analyze its own code. I said, how many comparisons are you doing per pass, per inner loop and outer loop? And I said, I'm doing like 2 here, 3 there, whatever. Right? It was a very imprecise answer. I'm not kidding. And at the point I remember it was like an test and A and B. And I said, but that's 2 comparisons, that's not 1 comparison. And I said, yeah, it could be considered 1 comparison or 2 comparisons. No, Esquire. No, Esquire, it's 2 comparisons, goddammit, right? How can you even claim, right? It even tried to manipulate me, right? So it can't actually, execute a loop mentally to figure out I'm doing a comparison here, I'm doing an increment, I'm doing this, I'm doing that, and back again. And it doesn't do that kind of stuff at all. It doesn't do symbolic execution, it doesn't do any of those. One really unpleasant thing, it was that it started to comply incompetently with me. Because whatever I say, you agree. I say, but this is wrong, you're doing too many comparisons here. And I said, yes, you're right. Let me fix that for you. And it generated code with more comparisons. Like, wait a second, there are more right now. You're right, even more. Right? It was not a good dialogue, and the more it went on, the worse it got. So, incompetent, compliant. I should add that all of this, there's a lot of talk about toxicity of ChatGPT and detoxification of ChatGPT and these tools. Essentially, they want to make these tools to not, kind of be nice. And actually, being too nice is bad too, because you want to say, what? I don't know. I can't do this. It never says I can't do this. It generates like a lot of code, and the more you press, the worse code it generates. And at some point, it starts generating things like unclosed parentheses. I got it to that point. So you gotta really annoy it. Gotta really annoy the heck of it. It has poor differential analysis capabilities. We're gonna talk a bit more about that. It claims that difference, so it's like, this is implementation A, implementation B. Which is better? They're the same. Yeah, I see. You notice that too. They're the same. No, they're not the same. Oh, you're right. They're the same. It's not a human dialogue here, right? So it got worse and worse and worse. And, we can't really carry a detailed discussion here. And I noticed that there's a notion of context fatigue that happens, the more context you add and the more you try and, improve a solution, the accumulated context and failed attempts actually are a net liability. So you're better off, let's throw everything away and start again. right? So this has been noted by many people in different contexts. It turns out for code, it's the same case. The more bizarre way in which ChatGPT failed the Turing test was very surprising. It wanted to write 1 million Bs. Like it leaned on the keyboard and wanted to let me show you. And it went on, and I was, you don't have to. And they said, oh yeah, okay, imagine 1 million. So the thing is, I'm not sure if you remember the famous scene from The Shining, whereby there's this guy the main character, Jack Nicholson, typing on the keyboard, and at some point his wife sees like this deck of written pages and looks at them, it's all gibberish. I felt that way, right? I felt that way. So, there's more. It's not all bad and it's not all good. That's the thing, there's blue and there's red. So it's great at generating, custom code for a variety of tropes that exist in C++. Give me code that does all that nonsense with templates and specializations and namespace detail and all that stuff, and it does it for you like a champ. And that's great because it means you're not gonna have to remember and write all of those mini idioms in C++ that are legion. There are so many, right? And it doesn't generate code that has rarely been written, like high-performance CUDA code that is like just in a few places. And the code that actually makes ChatGPT work, the matrix multiplications, that kind of stuff, is actually extremely difficult to write. So there are entire teams of engineers who sit on that kind of, it's called a GEM matrix multiplication. So, there's a lot of work that goes into implementing those and optimizing those. And there's also like the tutorial version, which is easy and kind of, simple. And that's what ChatGPT is going to give you right now. It's not going to give you the high-performance version. It's very good at explaining things like you come from Python to C++, what the hell is happening here kind of thing, right? And it's not a good interviewer, which is the most unpleasant detail. For example, ChatGPT interviewed A, B, and C. And it has like 10 classic C++ questions. What's struct versus class, and singleton, and virtuals, and polymorphism, and that kind of stuff. 10 questions, including writing code. And candidate A was the best. He did 90, 85, 95 on technical knowledge, problem skills, and respectively communication skills. Candidate A is the best. Candidate B was fair, pretty good. Not as good, but pretty good. Candidate C, by the skin of his teeth, right? Barely made it. Barely made it. 85, 75 problem solving skills, communication, 85. Not a good communicator. It noted, ChatGPT-4 noted, candidate A stands out for their detailed and clear explanations and their strong problem-solving skills. Awesome. Who do you think candidate A was? JGPD 3.5. Who do you think candidate B was? JGPD 4. Who do you think candidate C was? I barely made it. Barely maybe junior programmer. And I'll speculate on why. For example, I mentioned singleton actually is not such a great pattern. I wouldn't do it if I could, or I would do it with moderation, right? And they asked me it asked me to implement string reverse, return a copy of the string reversed. And ChatGPT 4 and ChatGPT 3.5, they took the string by const reference and returned the string by value, a copy, right? But I knew, the new idioms in C++, and I took the string by value and I modified it in place and I returned it, thus saving potentially one allocation. But it's not the way most code on the web right now does it. So ChatGPT said, poor problem solving, problem with authority, not very good, right? Not a good sign. You know, there's this joke that goes in management circles. It says, A people hire A plus people, and B people hire C and D people. JGPD kind of fits the B people kind of category right now, which is sad. I mean, it should differentiate at least between ChatGPT 3.5 and 4. Anyway, so to conclude this section, ChatGPT is a helper, but it's quirky, and it's not a good peer programmer for you. It's got a lot of prompt sensitivity. The output depends very much on the prompt. There's no clear sense of clear prompts that are going to generate reproducible outputs. It has this context fatigue, which is most annoying. So the more context accumulates and you're trying to improve a solution, the worse it gets sometimes. Not always, sometimes. It's got a cognitive dissonance problem whereby it's trying at the same time to agree with you and do its own thing, which is really annoying. And it's difficult to kind of get past. So it always agrees with you and that kind of stuff. So it should be able to say, I can't do this, no, I disagree and whatever. And it's got a bit of a lack of originality. I wouldn't put money on that this is going to be the case forever. Right now, that's why I'm saying ChatGPT 4, not any ChatGPT or any AI tool. So right now, it's got a bit of a lack of originality. It doesn't generate code that has seldom been written. It generates code that has been written a lot. But outside of research and us 1%ers, right? A lot of code has been already kind of written and is known. And so that's why I'm saying for application programming, there's a lot more juice in that stone for us. Let's switch gears a bit. We're gonna go a bit over time. So it's the last talk, and I'm gonna just push a bit against the boundaries here. I have so much on my mind. I need to share all of this stuff, right? We need to commiserate here. By the way, do you realize that the next year's conference is going to be very different? Yeah, it's going to be a complete different event. So the topics are going to be different. I hope the speakers are going to be the same. Right, Esquire? So let's talk about creativity, taste, and skill. And there's this, in arts, there's this trope that goes, good art requires all of the three: creativity, taste, and skill. You gotta have all three. If you miss one, you're dead. If you have no skill, no fluency, then you're gonna be a novice, a newbie, a dilettante. If you're good at skill and you're good at taste, but you have no creativity, you're gonna be a copy-paster. And if you don't have taste, that's probably the worst of all. You're gonna be awful taste but great execution. I'm not sure there's a group on Reddit. It's really funny. Awful taste but great execution, you're gonna be a maintainer nightmare. I'm sure we all have been through that point in our careers where our taste was not really developed, so we wrote bad code and we live to fix it. Or we live to fix other people's bad code, right? So the beauty of AI is that it makes the field even in terms of skill. And that's amazing. Remember that scene from The Matrix, Neo, right? They put that thing, Neo wakes up, I know Kung Fu, right? So a guy with, taste and whatever, so the guy with a lot of stuff, but he didn't know Kung Fu, in 5 seconds, he downloaded Kung Fu. AI is your Kung Fu. You download it instantly, you know instantly any API and any tools you want. So that's why once the skill thing is off the table, there are two remaining: your creativity and your taste. And these are gonna become your superpowers in the years to come. This is what's gonna make you fantastic. And you are going to use the AI tool as the third superpower. Okay? So skill is off the table, which is why many experts, they hate all of these using, many experts say, ChatGPT for code, it's a joke. It doesn't do anything interesting, it's like terrible, I hate it. But you gotta give it this fact. It completely unloads the skill of the table, right? So, what's this new world? With ChatGPT 4, it's very good at skills. And a lot of success stories come from people coming from other domains into, I wanted to write a Chrome extension. And I know zero JavaScript. I know zero about Chrome extensions. I have no idea what's going on, right? But I'm a programmer. I have the creativity and the taste. I can identify the right code. And all of a sudden, in half an hour, you have a Chrome extension going, which is amazing, right? So it knows LaTeX, PyChart, JavaScript, Chrome extensions, Sphinx, Doxygen, JavaDoc, you name it. It knows them all. It knows all the APIs. The fact that it knows LaTeX is already like 99% for me. I'm not sure if you like LaTeX. I'm seeing a few nods, like people who are they have it on their foreheads, like, oh yes, you see these signs on my forehead, they come from knowing LaTeX. Yes. So, when it comes to taste, JGPT has some taste, because it comes from the code it's seen. To the extent that there was taste in code on the GitHub and on the web, JGPT is also going to pick some up. Right? It's going to pick up because, as I said, human language is you're going to pick up whatever the hell is in there. You're going to pick up what humans do. And if humans who write code have taste, right? Let's pat ourselves on the back. We've done all the hard work in this business, right? We wrote that code, come on. Right? It's these fingers, these hands, man. It's these hands that wrote all that code, right? We did the work. And ChatGPT picked up the taste embedded in our work. So it's some taste. It's not a lot of taste because it can't assess new code that it hasn't seen before. So, consider somebody who takes a leap into an unknown, invents a new idiom in C++. And ChatGPT is like, I wouldn't know what to say about this. It does, it looks like you have a problem with authority, right? What's the deal with that reverse string that takes its parameter by value? Nobody does that, right? Creativity is one thing. It has some creativity because a lot of creativity really means combining old patterns in new ways. There's actually, it's part of the definition. Consider like the copy machine, like Xerox, right? The copy machine, the inventor of the copy machine. It is like three things that pre-existed. There's like, the photography, the whatever, the electrostatic ink, and, the paper mechanics, and all three existed. And he said, oh, wait a second, I could make a copy machine of that stuff. But it was not something that was qualitatively new in a way. I'm not minimizing the merit of the guy, right? But, the technologies pre-existed, he combined them, right? You can claim that kind of stuff about a lot of inventions, right? But that said, a lot of other inventions do require a leap into the unknown. You gotta kind of take the leap from here to, oh my goodness, right? To literally, like, you don't know where you're going, and that's the kind of creativity ChatGPT lacks at the moment. But I would not put money on that, because you never know. Like, 1 year ago, this time, who would have thought we're gonna have, a tool that generates like passable code even, right? So, that's awesome, because the good news is the creativity, taste, and taste are going to become, are already 10x more portable than fluency skill across different languages, different libraries, different APIs, different frameworks, whatever you have. And it's easier for non-experts, but it's superpowers for experts. Because again, the best success stories are not from people who have no idea about coding, write me a game. Those are not the best success stories. The best success stories is I'm coming from a completely different language, API, whatever, and I learned this in 15 minutes. And I got working code. These are the most compelling success stories because they come from people who had pre-existing creativity and taste. By the way, I should add, skill, creativity, and taste. You learn them together. Right? You're not a coder who has a lot of creativity and a lot of taste, but has absolutely no idea about coding. While you code, all that frustration that you accumulate while coding, right, causes you to lose relationships, but also accumulate taste and creativity, right? So they come in a way together. And the fact that now skill is off the table is an imbalance in the power. It's new, it's unexplored territory, people. It's new stuff. We don't know where this is going. This is the second uncomfortable silence of the day. All right? Oh, we don't know where this is going. Where the hell is it going? Am I still going to have a job? What's going on? Wait, let me call my boss. What's happening? All right, so let me give you an example of applying that creativity of taste. I'm not making grand claims here. I'm not going to say, oh, I'm going to invent right now something new in C++. But I'm going to come with a few micro ideas that JGPD can't come up with. So, I had a project and I wanted to have a small unit test framework. So there's this great talk about unit testing the morning of yesterday. And I loved it because unit tests are important and are very good for us humans, and they're very good for, automation and everything. So, they're good all around. So I wanted to have a very simple unit test that I count the complexity in hundreds of lines of code, not thousands, and that is tiny, simple, it's easy to learn, and I can define unit tests inside functions, which is a bit heretical, and I'll explain why. And I want to have things like test names that are strings, and Tim made a very good point that it's good to give tests good names and that kind of stuff. And I want to parameterize these tests. And the existing unit tests, they have very many thousands of lines of code. They're very big. And, I didn't like that. I said they're too complicated for what they do. So that's where my sense of taste was violated. I said, I don't like that. I don't like that I need to, import this huge project of like 19 or 39 or 129 kilolines of code just to write some unit tests, right? So then I said, I can define tests inside functions and that kind of stuff. So I was kind of unpleasantly impressed. So let's use a bit of that creativity and taste to get some tests done. And here's what I want. I want to say unit test at top level, and I give it a name, and it says expect something, and if not, it doesn't happen, I print an error message. And I want, for example, to test a sorting function that sorts, and I want to, unit test inside the function because the function is going to be instantiated with many types. So, I can't control with ease how many, what instantiation is going to have. So I'm going to have to plan the test that the thing is sorted inside the function. That's the weird thing about template functions. They can be instantiated with a variety of types, and you don't know exactly which types, right? So you want unit test inside the function. And you want to pass parameters to test. You want to say unit test whatever, and I'm passing the unit test. I'm passing a default integer. I'm passing a float, and I'm passing a string. And I extract the type from this unit test param, which is a parameter, to the unit test. And I'm going to run this test 3 times, not once. Once for an integer, once for a float, and once for a string. And notice that this is like only one, it's just one unit test keyword, pseudo keyword, macro, right? It's just one thing. It's not 100. So I just taught you how the library works. Took me a slide, right? It's really easy. But wait, there's one more thing that I wanted to convey, which is nested unit tests. Unit tests should nest. And the way this works is you start the unit test and you run it once for each nested unit test. And the common code is going to be the same. So that makes it for easy setup and tear down code. So you don't need text fixtures, you don't need anything, don't need any of these test cases and whatnot. You simply have nested unit tests and they take care of everything. This test is going to be run twice. First it runs, it's going to make sure size is right, it's going to expect size is 4, it's going to run again from the beginning, and it's going to push back to the vector, it's going to expect that the size becomes 5. And that's the way the cookie crumbles. By the way, this is not my idea. It's catch 2. It defines a section macro for that. But I want a taste. I want a single macro to do everything, right? So let's see. What everybody's doing is, whenever I say unit test, is going to define a class which has like 50 lines, and it has a virtual, it has whatever, and then you say void, whatever, test body override, and the user code comes right after the macro, right? So right after the unit test use, you're gonna open a brace, like there, you're gonna open the brace, and then your code is gonna come next, right? So that's how the frameworks do it at this time. But you can't define a class inside a function. You can't nest a class inside a function. So we have to do it a different way. And that's where that, I'm not making claims that, I'm not the most creative out there, but I will make a little claim that I had a micro idea. And my micro idea is, let's use a lambda instead of a definition of a function. Because a lambda is really it's anything, a statement, a compound statement, and, you can actually do something like define UnitTest name, static auto, give me a unique name, and this is the start of a lambda. And then you provide your code, and that's the rest of the lambda. And micro idea, right? That's nice. Good. So right now we have this micro idea. We know how to introduce lambdas with a macro, but we don't know how to execute them. But it just defines the lambda, it just sits there like an idiot. It doesn't do anything. So you gotta find a mechanism to execute the lambdas. And here's the micro idea number 2, which is let's overload an operator, an infix operator. You want to overload an infix operator because what you want is to define UnitTest name, static auto unique name equals make UnitTest, overload that infix operator, beginning of lambda. And at this point, not only I define the lambda, and I also define the UnitTest object, and I also have an operator that gives me a hook into executing that lambda. So I have everything at my disposal right now. I have the lambda, I have the UnitTest, and I have the means to execute. Like, the UnitTest can take the lambda, do whatever the hell it wants. It can execute like 1,000,000 times. Right? No problem there. So that's micro idea number 2. Micro idea number 3 is, let's pass parameters into the UnitTest. Who knows about VAOPT? Raise your hand. VAOPT. Yes, thank you, Tim. No, it's not actually, it's new. But it does something that was needed a long time ago, which is, if you pass some variadic arguments to a macro, it's going to expand to those, to something, to itself, to its content. If you pass 0 arguments to the macro, it's going to expand to nothing. So VAOPT takes care of this goddamn comma here. Do you see that comma right after VAOPT? That comma would completely ruin my day if it was there and then followed by nothing, by close parentheses. With VAOPT, I get to if there's no argument, actually that comma should disappear. So you make that comma go away. So I highly recommend, if you want to write variadic macros, which I wouldn't recommend, to look into VAOPT, right? It's a great tool. So anyway, we have this micro idea number 3. I'm going to pass the arguments, and the UnitTest is going to take one at a time as a parameter into the lambda. So now you have these 3 little ideas. Number 1, use a lambda instead of a method. Number 2, use an overloaded operator to launch the lambda. And number 3, use this trick to pass values into the lambda. 3 micro ideas, right? And from here, it's like a straight path. You define UnitTest as a template class. It takes variadic parameters because we can instantiate the UnitTest with 0, 1, or 15 parameters, and they're going to match a very nice variadic class with as many arguments to the template as parameters we pass to the macro. So it's all going to work smooth, and notice this operator arrow star, which is taking the lambda and is going to run the lambda and recurse whatever, right? Iterate. So that's it. We're kind of done with this, which is nice. And my point is not, I'm not claiming that this is kind of awesome stuff or whatever. I'm just claiming that JGPD 4 had absolutely no idea what I was doing. It had absolutely no idea. What the hell are you talking about? For example, I asked JGPD, what is cool about overloading operator arrow star? And he said, it's cool that you overload it. Good for you. It doesn't have a real answer because nobody in their right mind overloads that operator, right? Nobody in their right mind has ever done that kind of stuff, right? So it was impossible for JGPD to combine these 3 ideas together into a working strategy because it does no planning. It does no planning. It has no sort of, leap into unknown. It does not do what has not been done. That kind of stuff. So it was impossible. The most interesting experiment was the clean room approach. Instead of saying, define me a UnitTest macro, I said, define me a macro A, B, C, D, E. That does the following. And at that point, he kind of started to think. It said, a Lambda may be good here. But it didn't go past that. It kind of stopped at the Lambda. It didn't know, like the infix operators, all the operator overloading stuff, it couldn't do. But that was an interesting tidbit, right? And the most funny thing is that when it starts panicking, it generates like really bad code that's incorrect syntactically and that kind of stuff. So it's terrible. Anyway, once I got to overloading that weird operator, I figured that it's a pretty cool thing to overload. Why? Because it is the most tight binding operator of everything. It binds the tightest of all operators. And I'm not kidding. The way I figured this out, I Googled operator precedence table C++. I looked at the table. I picked out the top thing that was overloadable. Right? That was my scientific method. Right there, right? So I figured, okay, so this is like the most interesting. So that actually makes it very interesting for something else, which is a derived micro idea. And the way the derived micro idea works is, let's see that expect macro. Expect. Everybody who's used unit testing in C++ knows that people define expect equal, expect different, expect less, expect greater, expect like in Fortran. All of these suffixes look like Fortran. But actually I wanted to do, simple, just one macro, taste. Just one macro does everything. And the way you do it is you say expect, I'm going to call a function validate, and I'm going to call a function capture that uses this operator, and then veridic arguments. Without a parenthesis. Without a parenthesis around the arguments. Which is heresy. Nobody should do this. Except when you want to. Right? Because once you did not put a parenthesis, expect A equals B, becomes validate capture arrow star A equals B. How's that expression going to be parsed, friends? Who's going to bind first, the equal or the arrow star? Arrow star. So at that point, this expression is going to be captures arrow star A, that's going to be part one of the expression evaluated first, and then the result of that is going to be compared for equality with B. Oh, wait a second. So then I can define a little expression template that is called capture, is a struct capture that is defining this operator to take the left-hand side and the right-hand side, and it's going to return me a term. That's how all expression templates library do it, and essentially that term is going to define in turn operator comparison, less than, greater than, etc., 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 and it's just going to work beautifully. So then if you say expect A equals B and it fails, you get access to both values, not just the Boolean result, in an expression templates manner. So it's going to print this to the standard error. I'm expecting that this is, that it didn't work, but it's going to be able to print the numbers. Better yet, because arrow star is the tightest binding operator of all, you can actually get a hold of the entire AST of the expression. And you can say, 42 plus 73, you said it's going to be equal to 100, and it's not. So it's going to print all of the operands for you, which is quite remarkable. It's not my idea. It's not my idea. libassert and lest, two existing libraries that do that. But JGPD did not find them. It didn't know about them. Because I asked JGPT to do this kind of stuff. It said it can't be done. It didn't say that. It tried a number of completely moronic solutions, and in the end, it gave up. But essentially, people came up with this stuff. because they combine operator overloading with expression templates, and there's a micro idea. But JGPD did not figure that out. In a way, one can claim these are 1%er solutions. Few people are going to need to do these tricks, write these libraries, do this kind of stuff. But the fact is, at this point, JGPT has no access to these kind of micro ideas. Last but not least, I'm going to make a number of predictions. And we're going to go. I'm sorry for keeping it so long. Prediction number 0, because we come from 0 with C++ programmers. Prediction number 0, soon you're going to have this in your build pipeline. Make widget.eng, English. Or Paul, it knows Polish. Actually, I looked ChatGPT, does it know Polish? Sure. Right? So make widget, read class widget from this file, generate a class that uses the pimple idiom, use a shared pointer named that way. For methods that return an error code, convert it to CUDA exception, throw the exception if it's not 0, return void. Do not implement whatever, it's implemented by me. No need for comments, generate line directives, output to the file generated widget. That's going to be in your make file. It's going to be in your CMake. And there's going to be a tool that's going to generate that code for you. And this is going to happen by this conference next year. For some teams, it's happening already. There's research on that. That's reflection for C++ done with natural language. Which is, I got to tell you, I got into NVIDIA with my talk on reflection in C++. And now they could fire me because, all my work on reflection is actually, there's no need for all that stuff because we can do it with English. Right? So pretty awesome. Prediction number 1. Planning and long-term are coming. Picture this. What would your life be if you always said the first thing that comes to mind? People will hate you, right? And say, oh, you're an idiot. Whatever, right? You'd be like, oh, what the hell? Why did you say that? Well, it was the first thing that came to mind. You're ugly. Whatever. So you can't say, people don't routinely say the first thing that comes to mind, and that's part of what makes us great and human. But actually, that's how JGPT works. Did you notice that no matter how complicated a question, ChatGPT always responds with the same speed? Did you notice that? They always the same speed. You ask let me think of a prompt that's 30 lines long, and it's yeah, sure. It's you're 5 more words, same speed. Right? Why? Because it says the first thing that comes to mind. It has no iteration. It has no thinking, no pondering, no rules, no if, no else, no loops, no nothing. It's 96 matrix multiplications. That's it. It's all straight line. That's why it's so fast, because it's optimized it's just straight line code. There's no if then else. It's just and it comes. So in the future, there's definitely going to be some iteration coming, because I'm not sure if you know the curse of the 80 cycles. 80 cycles is the number of neural cycles that we take to recognize a pattern. So if I look at the face to distinguish that face from a bag of potatoes, it takes me 80 cycles. We have no idea how to implement an algorithm that takes 80 cycles in a GPU to recognize a pattern. We know one that takes 1 billion cycles, but that's much slower, but the computers are much faster, so we kind of come forward, right? But the thing is, human brain works in 80 cycles. And if you want to reason some more, we gotta do those 80 cycles multiple times, right? So that's why I start thinking about things and reasoning and kind of going back and forth. And I'm trying this solution, it doesn't work. Let me go backtrack and start trying something new. That's how you implement a function in programming. That's how you write most of your code, by going back and forth on any non-trivial problem. JGPT does not do any of that right now. And definitely tools are coming that are going to start doing this kind of stuff. I gotta tell you that there are a lot of folks who do this as a hack. AutoGPT and a variety of tools kind of have these, these automatic ways of iterating through solutions. So multi-step. Prediction number 2, swarms. So right now, it's you and ChatGPT, right? There's one context, one goal, one objective, one memory. But, in the future, you're going to have like multiple of these agents communicating with each other. And that's a great way to scale up. Consider this. In any programming project, there's a project manager, and there's like a team lead, and there's programmers, and there's a hierarchy going on, and there's communication, all that stuff. And the project manager does not know about the last line of code. They don't have room for that context in their mind, right? So the way it works is the project manager knows at some level of detail what needs to be done and what's done, and then the team lead has some idea, and each programmer knows their own context, and that's the same way it should go about these things. Because you should have a ChatGPT that knows about the large context, and you should have several ChatGPTs that know about each little detail. Keeping everything in one place is not productive. You gotta have some hierarchy. So AI tools for code will integrate swarms of communicating. I should say that people do already this. People do this as a hack. They use, they instantiate multiple agents, they have them talk to each other, and just let me know when you come with a solution, that kind of stuff. So that's coming. That's in a way already here. Number 3, institutional memory. AI tools will be able to load things into institutional memory. Institutional memory is like a company, all of the code base of that company. So it's a personalization mechanism, right? So you want to have our company does code in a specific way. It has a specific area of knowledge. It has certain specialization. It has a culture. It has a way of doing things. So what you want is to load all of that institutional memory into the tool. And the tool comes pre-trained, and then you fine-tune the tool with your own code base and whatnot. So that would be the institutional memory. For people, it's kind of difficult. You gotta kind of learn these things and transfer them from short-term memory to long-term memory, which is kind of a process that it's difficult for our mind. But with computers, you push a button and it's like, oh yeah, sure, load this into whatever memory, right? So that's coming. And last but not least, AI tools for code are going to integrate with today's tools. There's already some work on that. I highly recommend you look into ChatGPT. So it's a debugger that whenever a program fails, it tells you why. This is a great kind of soft skill, like it's a soft tool. It doesn't always say the exact thing, but it gives you a good idea. So there's all like CY, so there are a number of tools coming. So Emery Berger is doing research on this stuff. He's got a number of tools at Plasma UMass. So I very much recommend that kind of stuff. But essentially right now, again, ChatGPT is operating blindly, but consider this. You marry ChatGPT with godbowl.org. Boom. It can, generate code, look at this assembly, look at, execute it, see if it compiles, if it runs, what it does, and that kind of stuff. Give you table, benchmarks, instrument the code for you. Like, it's very easy to give ChatGPT a function that's 100 lines long and say, oh, instrument all increments of this variable for me. Boom, no problem. So instrumentation is going to become something that's trivially done by tools in ways that you don't even need to worry about. You don't even need to look at the code anymore, right? So, sorry, this is the last prediction that I wanted to make. I spoke to Tim a bit about that, which is between code, documentation, and UnitTest. Which one do you write first? Hands up if you start with tests. 1. Okay. Who starts with the documentation? 1. Who starts with the code? Okay, everybody else. That's what I thought. So in the waterfall method, you always start with the documentation. Boom, let's write the spec. You write 1 million pages, and then you say, oh, let's throw it to the programmers, right? In TDD, you start with, obviously, unit tests. You start with the test, and then you have them inform your implementation. And pretty much all of us, hoi polloi, unwashed masses, we start with the code. And write the code. We never write the test. We never write the documentation, and that's the way it is. And let's face it. But if you had that unit test that I wrote, that would be awesome, right? So, fine. What do you think is going to happen when you have AI tools? It doesn't matter which one do you write. Thank you very much. Notice that all methodologies of today, without saying it, assume that we need to do all that stuff. Every methodology assumes it's going to be a human being that's going to write this documentation. It's going to be a human being who's going to write that unit test. But wait a second. In a world where there's no more people who need to do all this stuff, what are you going to use? You're going to use whatever method is best for the machine. And you may iterate and that kind of stuff. For example, if you ask Tim, would you generate unit tests from documentation or from code? Difficult question. Would you generate, let's say you have documentation, you have code. What do you give a tool to generate code for unit testing from? Both. Who says both? Okay, who says code? Who says documentation? Who says, why the hell am I still here? So, the thing is, folks, you're going to generate different tests for the code, which are, they're going to be coverage tests from the code, and you're going to generate unit tests from the spec. Because the unit tests from the spec without the code, they're going to be quite different from the unit tests that see the code. The unit tests that see the code are going to test for coverage. They're going to say, oh, I'm going to go through all the ifs, analysis, and branches and stuff. But the unit tests from the code are the actual unit tests because you want to test the functionality that was intended, not that was implemented. So you're going to generate from both, thank you very much. But the point is, in an AI environment, there's going to be tools that are going to do a large part of the work for you, so you're going to use whatever method. We are in unexplored territory. We have no idea what's going to happen, but something's going to give. Something's going to happen, and we're going to change our methodologies. With this, let's summarize. So I would claim that these tools are going to be extremely, extremely solid, influential for us. Even right now, there's a lot of sizable application, even to systems code. For all my criticisms, I would say it's a great assistant to use for a variety of tasks. Your creativity and taste are becoming your superpowers, so hone those. And for skill, ask JGPD, right? So hone your creativity and skill because that's what makes you different and that's what makes you great. There are quite a few unpleasant things, but those are not a problem for existing programs. They are a problem for beginning programmers. Definitely, the stuff is going to get a lot better, but right now, because you're an existing programmer, you know how to evaluate and judge because you have the taste, and you know what to create, so you have the creativity, right? And for you, that's not a big problem. Make no mistake, we are living historical times. Again, next year's conference is going to be quite different from this one. I hope I'm going to still be invited after this talk. These are historical times we're living. And don't forget, the way these AI coding tools are right now, they're the worst they'll ever be. Thank you very much.